My name's Nigel Kersten. I run operations like sysops, internal IT, and business operations at Puppet Labs. And yeah, it's really great to be here. I always love a good excuse to come to Berlin. I really love electronic music, and so for me, Berlin feels like the spiritual home of techno. And so I always have really good reasons to try and stay the extra weekend. And hopefully you'll see a few synthesizers coming along in the theme here. So I'm not going to try and sell you anything here at all. This is an open source conference, but I'm not even really here today as, Puppet Labs, Puppet the open source project. I'm definitely not trying to sell you anything. I'm here, I guess, more of as a user. We've sort of grown pretty hugely, I guess, in the last few years, and we're now nearly 400 people. We've got offices in London and Sydney and Stockholm and all these places. And I run internal IT, so I kind of have these problems as well, and we're at that size of a company of developers going crazy using cloud services, and suddenly the bill's coming in every month, and we're trying to do that sort of work out, what's the best way to build infrastructure? Where should we do it inside the data center? Where should we let people use the cloud? How can we give people guardrails? And how can we kind of do it without saying no to everything? Because I think this is sort of the old way of doing operations in many ways. So I wanted to ask a few questions just so I get an idea of where you're all at. Who runs all their infrastructure, or at least most of their infrastructure, in their own data centers or colos or server rooms? Who's running pretty much everything in the cloud, like public cloud services? That's pretty cool. You'll see, I have a slide on that. How many of you work in really big companies? Okay. What you think is sort of big. How many of you still have all your servers on like racks and desktops sitting under a table somewhere or in a closet rather than actually in a colo? It's okay. Don't be ashamed. But that's kind of cool. And so I think the mix is, as Chris, pointed out, there is kind of a difference here between Europe and the US. And I think some of it comes down to trust. Some of it comes down to like different sort of constraints people have. But there's definitely a whole bunch of hype around the cloud. And I don't think you can't really deny that there's a whole bunch of things that are really, really awesome about using cloud services for everything. But in this talk, I'm basically going to be arguing that I think you can get a lot of the advantages of a cloud, public cloud services, in your own data center. But you've got to do some work to kind of get there. So I'm not a cloud hater, on the other hand. Like, there's lots of things that are really, really useful about it. And I don't know if the term cloud washing is something you guys are all familiar with, but I saw this the other day. I was visiting a friend who's totally not technical, and he's like, oh, I've got a cloud hard drive. I was like, what's a cloud hard drive? He's like, oh, there it is there. And he's bought some hard drive that markets itself as a cloud hard drive because it's got backup, and the backup goes somewhere else. And so I think, the term cloud gets completely overused, and people abuse it in all sorts of ways, and just like any marketing buzzword, whether it be DevOps or Agile or whatever, you're going to have people there who are sort of abusing the term for their own sort of gain. But I think there are lots of advantages, and it's not all just cloud washing. There are things that are really, really useful, and I think one of the cool things about the cloud is it sort of forced a mindset change for those of us who actually run data centers. So to sort of be transparent here, we use, at Puppet Labs, we use cloud services, we use Amazon a lot, we use Azure, we use Google Compute, not just because we partner with those people, but because sometimes it's kind of better. But on the other hand, you don't necessarily want to give your developers an unlimited sort of debit card just to keep paying for services every single month. And a lot of the time it makes sense to just own everything for a bunch of different reasons. The other thing I think to point out is the cloud is someone else's server. Like, there are things that are different about it. There's different things about the way we use it. But there's still other people's servers, And maybe that's part of the problem. They're other people's. They're not yours. But there's things that are really, really good about the cloud that we can implement on our own infrastructure really easily. And I think, a lot of people have this sort of doom and gloom about the state of operations and infrastructure going, everything's going to move to the cloud, and we're just going to end up with 90% of the world on Amazon or on Google or whoever it ends up being. But I really don't think that's going to end up being the case. I don't think we're going to end up having fewer servers. If you look at, 5, 10 years ago and you talk to your average person, and you asked them, you thought about how many servers they interacted with, they weren't that many really. But now, consumers have all their stuff all over the place, and they're used to consuming services, and all of those services require servers. So I don't think there's any world we're moving towards where we're going to end up having fewer servers to have to deal with. Does anyone else run this? This is a really awesome Chrome extension if you haven't seen it before. And it basically, every time you surf the internet, instead of the word cloud, it just replaces it with but. It's a really nice way of kind of puncturing all of that sort of hype around things, because there's nothing that sort of gives you a little bit of glee, like being able to read a press release, like Microsoft's profits slide, but its butt flourishes. The only caveat I have there, and I think we're not the only, this became really big at Puppet Labs and everyone installed it, and then turned out even the marketing people were installing it for a while, and then they were using the content management system to write documentation. And it'll happily replace cloud with but anywhere. So it was pretty funny seeing the Gartner and Forrester but reports on, how but expenditure's planning to increase. One thing I find really amusing here is it's actually done it in its own project. The project's called Cloud to But, but it's gone and replaced it for itself with but to but. So here's a bunch of sort of, you're hearing all this stuff from people all over the place, how much cloud expenditure is increasing. These are the usual suspects, it's Cisco, it's Forrester, it's Computerworld, it's the industry magazines. They're telling us people are spending more and more money. They're spending more money on infrastructure in general, but cloud expenditure is exploding and billions of dollars are being spent all over the place. And, we saw from the crowd, most of you are actually running data center stuff primarily and not necessarily using the cloud. But I don't think these people are stupid. I think people can be stupid, but they're not that stupid. Like, there's reasons why people do this. It's not always easy to convince businesses to spend money. They don't always do it in a really sort of sane and rational sort of way, but they're not that stupid. There's a reason people adopt all this stuff. So what are the traditional arguments against cloud? You don't have any control anymore. It's not your stuff, it's someone else's server. You don't get to dictate, when performance happens, hardware upgrades, all of these sorts of things. You don't necessarily even get to dictate a hypervisor. There's all sorts of inflexibility with using a cloud. You get locked into vendors. And I see this a lot from people, and I think it's going to be really interesting to see how cloud usage over the next couple of years changes. We're seeing people already going, well, I use Amazon, but I don't want to be all in. I don't want to use S3 and EC2 and their messaging system and their CDN, because then you end up in this really sort of locked-in space. And I think our industry kind of hates monopolies in a way. We saw in the 90s there was a huge backlash against Microsoft sort of having this real monopoly, and it didn't really create the innovation that we really, really wanted. Performance kind of sucks. How many of you, the first time you actually did anything with a disk in the cloud, went, oh my God, what is... it's like I've gone back 15 years in terms of disk I/O performance and CPU performance. It can be pretty crappy. It's not that cheap. And I think this is one of the things I find really frustrating about cloud evangelists. They'll sort of push this whole thing of going, it's micropayments, but those micropayments keep going on and on and on and on. And there's a difference between spending money on hardware and spending money on subscription services. And there's lots of good things about it, but these are sort of the traditional arguments. Then there's security. And there's a bunch of reasons why people worry about this stuff. Having single points of contact, for people to be able to control the flow of information and observe information. And it's not that this stuff doesn't happen outside in data centers as well, but it's really, really easy if everyone's email's on Gmail, to be able to go and get various bits of information. And I think we've all seen the US government's kind of overreached in a whole bunch of ways. And it's not just them, it's GCHQ in London. There's real concerns here. And so there's a lot of fear, I think, in a lot of arguments against the cloud. That's kind of not where I'm going though. I don't really want to sit here and try and scare you all about cloud services. And I don't think any of us should be running data centers because we're afraid of the options. We should have a much more sort of positive aspect than that. We should be able to, say, What is it we actually want to do rather than running away from the things we're scared about? And I don't think it's a binary choice. I think there's a real spectrum here. I think one of the really cool things with a lot of the big data center providers, even the smaller ones, is all this sort of functionality that's there now that lets you mix and match. You know, if you want to use public cloud services because the risk is right for you, or it's the right kind of functionality, or you just want to be able to burst out, you can do that sort of stuff really easily. It's no longer really the state I think we're in when Amazon first launched EC2, where you were largely on-premise or you were largely in the cloud. I think those lines have gotten much more blurred these days, and you can sort of mix and match features from different providers. You know, we've got interconnects, we have telcos inside data centers. We can, you know, pay for dedicated bandwidth to Salesforce or SAP Havana or any of these sort of services. We can pick up things like that. But I think fundamentally I'm going to argue that I think diversity is good. We don't want to end up in a situation where we have any company kind of controlling one of our foundational infrastructure layers. And I think this is a lot of the fear that happens. And I think this is a justified fear. And it's not just because you think they're going to do something wrong. I think innovation is good. You know, look at the problems if you want to sit there and you're like, okay, well, I'm really all in on OpenStack, for example, because I actually think it's going to be really good. It's not always easy to layer virtualization like that. You know, like Amazon's largely Zen-based. You don't necessarily have the Intel VT performance bits that OpenStack really relies upon. You can't necessarily innovate in the cloud. And I think some of the constraints, and this is sort of the direction I'm going to go in, the constraints of the cloud are what sort of enable a whole bunch of innovation. But at the same time, I think we need multiple solutions around the place. And I actually think this is where open source is so critical in terms of the data center, because open source projects need to glue things together. There's a direction that the internet's going in that really worries me, where I worry we couldn't even invent a protocol like SMTP or IMAP these days. Consumers have moved to this model of they only want to pay small amounts for software and they prefer to pay for services. And when services integrate with each other, they're not always as open as they should be, particularly not when companies are running them. So I really sort of worry in some ways about the future of the internet. We've sort of educated our user bases. You know, you shouldn't go out and, you know, pay a bunch of money for a really great client on an open protocol with an open server. Instead, we've got all these services that are slowly turning into walled gardens as they work out how to monetize different bits of your information. So I think we need innovation. We need lots and lots of options. And ultimately, I think owning the hardware layer gives you a lot of those options. And it's not always going to be right for everyone, but I think it's going to be where we're going to see a different kind of innovation come out. And if you look at a lot of the projects that are, you know, being talked about here, that was covered in the workshops yesterday, this stuff is where lots of innovation is happening. And it's not just in public cloud, and it's not just on-premise. It's about sort of opening up protocols and letting things talk to each other across those boundaries. So why do people do it? There's a whole bunch of definitions of the cloud, and I think they all sort of center around a whole bunch of things. It's on demand. You know, you want something, you can go and get it. It's self-service. You're not going through the bottleneck that I think operations and IT people need to kind of own up to, that we've kind of been the people saying no to our internal users and some of the rest of the company in many ways for the last few decades. It's really convenient. Users' expectations have changed. You know, if you want to use, developers go, wow, well, I could ask you to, you know, file a ticket to get a new repository set up with access permissions, but they've used GitHub. You know, they've interacted with it. And so their expectations are different. They're like, why can't you give me this control? Why can't you put it in my hands instead of waiting and ultimately being the person who says no? I talk to a lot of big companies, and big companies tend to be the most dysfunctional ones here. And it sort of horrifies me, but it shouldn't, because I've been watching this for years. You know, I just visited a bank recently. A big company should be really good at technology. It's 6 to 9 months when they finish an application before they deploy it. This is bullshit. Like, this is just unacceptable. No wonder people hate IT people. No wonder people hate sysadmins. We're kind of in the way all the time. And I don't think this has to be the case. It's elastic. You know, elastic gets used in lots of different ways, but you can just create more of stuff. You don't have as many quotas. It's just limited by your credit card in many ways. But that's really convenient for people. You know, circumstances change. A project that they estimated would have 100 users suddenly has 1,000 users. It's really convenient to be able to just create more infrastructure like this. And it's transparent consumption-based pricing. You know, you have some idea of going, I'm going to use X, it's going to cost me this. Now, because people are really bad at estimating, they may get that estimation wrong, but there's no longer these sort of hidden costs. And I think this has been one of the problems with IT too. We've sort of kept that stuff to ourselves for the rest of the company. You know, one of the things I really liked when I first joined Google, because I did actually used to work at Google, was that if you went internally to use, they use Ganeti for their infrastructure, if you went and requested a box, there was just a little marker next to it that went, this is how much it's going to cost the company. And I think you should put that information in the hand of users. I really like that. This is one of the things we're trying to work on around OpenStack. How do we take our existing hardware and show users, you know what, this is how much it'll cost if you do this, this is how much it'll cost if you do this. The story I heard at Google was before they did this, everyone would go, big instance, 8 gigs of RAM, fastest disk possible, go. And then they'd run some crappy little Node app, which might run away and eat all of that CPU and RAM, but that's sort of not the point. Then they introduced this thing and they just went, this is how much it costs. And it doesn't even matter if that money doesn't map perfectly, but giving people some sense of that. I really think if you give people information, they'll generally do the right thing. If a developer's looking at going, I don't need to oversize this instance, it's just some dev box. It doesn't matter if it takes 10 seconds rather than 5. They'll kind of do the right thing. Because again, I don't think most people are idiots. So this is one of my favorite drum machines in the world. This is the 808. And bear with me with this. The 808 came out and it's a really, really amazing drum machine, but it's really, really limited. If you have a look here, this is the step sequencer. So over a bar, you only have 16 steps. And there's a few things you can do. You can kind of create swing, you can do little things to sort of create stutter and sort of give you a bit of variation. But this is nothing compared to having a drummer. If you have someone who's a drummer there, they can sit there doing, you know, little triplets all over the place, little fills, there's lots of feel, they can move back and forth. And that's how we'd sort of produce music in lots and lots of ways. But what I'm arguing is I think the constraints around this system, which was also really cheap at the time. Drum machines were really, really, really expensive. And the 808 came out and had all this flexibility, but it also had a crazy amount of constraints. That's not many very different places for a sound to happen. And so I think what happened was we started seeing people dealing with those constraints, and that creates another kind of innovation. Electronic music kind of exploded after that. If you go back and look at this drum machine, a lot of what people started doing were just really simple breakbeats. Really, really simple sort of steps, really simple rhythms, you know, or even really 4/4 beats, just a drum machine kicking on every beat. This exploded into this like huge scene that, you know, still is like one of the most, you know, I think electronic music has now completely crossed into the mainstream because there's lots and lots of really awful stuff, which is probably a sign that it's gotten really popular. And if you talk to anyone who's like an electronic music nerd, they're going to be really annoying because you'd be like, what sort of music do you like? And they're like, well, you know, I like micro house, future, jazz, post-jungle. And they'll come up with these crazy, crazy little micro genres because it's how people kind of communicate. But I think the reality is you look at, and this is just one small bit of one of the maps out there of electronic music genres. All this innovation happened. And these are really, really different scenes in many ways. Like the difference between the people who, you know, are in London listening to drum and bass versus the people who are into sort of really happy hardcore house. These are completely different worlds, and they don't even really consider themselves siblings in many ways. But they all came out of this sort of, these constraints of really simple rhythms producing innovation. And I think there's an analogy here with design. If design's done well, if you're actually trying to design an object or a system for a user, in many ways I think the best way to think about it is you're making decisions on their behalf. You don't want to give them infinite choice. Because that's sort of what we like dealing with. We like dealing with infinite choice, we like having all this flexibility, but for someone who just wants to get something done, you know, simpler often becomes better. You want to make it so, they don't have to think anywhere near as much. I think if you look at the cloud services, they were like, well, what do people want? Click a button. I want to launch an EC2 instance. I want to fork a GitHub repository. I want to just create a new account in Google Apps. These things all became really, really simple compared to sort of the myriad ways we had to do things before. And I think good design does this for the user. There's bad design. This is a really amazing website, if you haven't seen it before, darkpatterns.org. And it's kind of where evil UX and user experience people go. If you've ever, and I get this all the time. I was away on holiday for 2 weeks and I've been traveling. So I have a ridiculous amount of email backed up. So I'm like unsubscribing from random marketing emails that I never signed up to in the first place. And I spent 4 hours doing it the other day, which felt like a ridiculous waste of time. And it was interesting looking at how different all of these people's unsubscribes are. There are companies who are actually pretty good with this. The email has a clear link, you go unsubscribe, and they go, thanks, sorry, if you ever want to get in touch with us, here you go. Then you get other people, you click on the link and they're like, what email address did you sign up with? And you're like, you know what email address I signed up with, I'm clicking on it from my email. The only reason you're doing that is to create friction. And then they will do something like autocomplete will put a space at the end, and then they'll go, well, sorry, we don't accept email addresses with spaces in them. There are ways to kind of design and make decisions that aren't for the user. And I think this is sometimes what we've also been guilty of in operations. We make decisions that are for us, not necessarily for the people who are consuming our services. So I highly recommend this site. Just going through the sections on unsubscribe and, horrible things where it's really difficult to mouse over to get to the contact and report abuse button. And there's ways you can really abuse this sort of process. So if you look at the things that really suck about the cloud, I'm going to argue that I think these constraints are actually what sort of created a whole bunch of innovation. And we can actually implement these same constraints because they're actually good things in our own data centers. It's unreliable in terms of you don't know when it's going to go down, much more so than your own hardware. You might get a maintenance outage, an AWS zone might go down, and you don't actually even have any control over that. The performance sucks, as we kind of went through. It took a long time before we started getting really big cloud instances with Amazon. And I still think it's kind of hilarious that I think if you go to the highest Amazon performance tier, they're essentially giving you a server. Like it is just a single server. There's just tooling on top of it to make it feel like you've got more options. It's also isolated from your existing infrastructure. And I think this was a real problem for a lot of people because the security model of a lot of companies, and I don't quite know what the German analogy for this is, but in the US I'd call it the Krispy Kreme donut analogy. You have a thin, crispy layer of security on the outside, but it's just all chewy dough on the inside. People go, it's behind the VPN, it's behind the firewall, it's totally secured. And then so people started deploying stuff in the cloud and they had to start thinking about security in a different way. It's unreliable in a bunch of different ways. You don't know what performance you're getting. You're sharing that stuff with someone else. You don't quite know what else is going on in the hardware. You don't know what background maintenance operations are going on. If you've ever sat there and benchmarked lots of infrastructure as a service instances, you'll see some pretty wild variations going on, even just over time. But I'm going to argue, I think this is a good thing. One of the biggest constraints, I think, is that the cloud just doesn't care. You get an email, we're going down tomorrow. Restart your instances. There's no pushback. How often when you're inside a company and someone goes, hey, I need to do network maintenance. And then another team goes, well, you can't do it that day because we've got a release. Or you can't do it that day because we're just about to push out a change to something else. And you end up with this silly back and forth where people start negotiating maintenance windows and change becomes slow. But if you're using a cloud service, you'll get an email from Google going, Google Compute Engine, it's going to go down for 20 minutes on this day. And you just have to deal with it. You don't have any choice. But I think this is a good thing because it means you move quickly. It means people started absorbing different philosophies about how they actually do operations and infrastructure changes because they just had to deal with this sort of fundamental unreliability. You don't have any control over all sorts of things. They may be sort of slight network blips at the edges of the routers. You may be seeing just bandwidth constraints going on. You may just find that some zone has been over-provisioned and everything just goes to shit. You don't really have any control of this. You don't get to push back on what they're saying, and you just have to deal with it. It's also, there's been this perception, I think, that public cloud servers are insecure. And I mean this in a different sense from secure from government prying and the other things I talked about. It's that it's out there on the internet. It's no longer inside the data center. It's no longer behind your, crispy shell of security. It's out there, and you've sort of got to deal with that communication is going across the internet. And I think these things caused us to really, really redesign how we do architecture of systems. And I think this has been a good thing. On the right here, we have like an old modular synthesizer. And this is what all synthesizers were like for a long time. You had to patch everything together. If you've ever seen one of these in operation, I think I've got a few shots later, there's just cables everywhere. You can't remember where things are necessarily plugged into. And they were analog underneath. Their pitch wobbled all over the place. And there was all sorts of crazy sounds you could produce with these, but they were expensive and they were heavy. If you look at the difference in the user interface of a really classic synth, the Yamaha DX7, this may be the worst user interface known to man in some ways. There's a data change knob here, and you've got this tiny little LCD screen that you get to essentially toggle through one by one to change parameters. But it turned out users didn't actually want this most of the time. Most musicians just wanted to make music. You couldn't store presets of this very easily. You could maybe take a photo of the whole thing and then go and redo it afterwards. The DX7 came with, I think, 500 presets. And the hilarious thing about this synth is because the interface is so bad at changing anything, you buy them secondhand now, which is what, 35 years or something after they came out, they all still have the same presets. There's no ability to reset the damn thing to factory settings. But the thing is, they're all at factory settings all of the time because no one could work out how to change it. Partly that was because it was FM synthesis, and I don't think anyone actually understands FM synthesis, really, unless you're probably an audio programming professional. But these things were huge. They sold by the bucket load. And why? Because I think they did what people actually wanted. The designers from Yamaha went, you know what? We're just going to give people a whole bunch of presets. We're going to give them a way to edit it, but we don't really want them doing that. But it's going to be in tune every time they turn it on. It's light. It's made out of plastic. They can stick it in a flight case. They can take it on the road. And these things became way more popular than any other kind of synthesizer. There's still so many of them around. And I think that's because you've got this spectrum. You can have a really, really flexible system, which lets you do all sorts of things. But users want affordances. They want ways of doing the thing they're actually trying to do. So I think the cloud forced a whole bunch of changes in operations. Devs don't need your approval. How many of you work in organizations where there's like distinct developer and operations groups? How many of you have those teams joined together? Okay. There's been all sorts of talk about this, and I'm not going to go lots into sort of the DevOps movement, but I think devs not needing your approval was a really big deal. Companies realize this. There's a reason why a lot of the software as a service providers keep their subscription costs below the amount an individual person's credit card approval within a company often is. It's because they get to just go do it. They don't need to ask for permission from management necessarily. They'll just go and develop something, it'll be useful, and then the rest of the organization starts using those services. They have APIs and tools to do what they do. We've been really shit, I think, as operations people at building infrastructure in our data center that has an API. And I think this is one of the most interesting things about most of these projects we've got being demoed here in the next few days, is that people have realized, you want programmatic API access. It's not just about interactive command lines. There's only so much you can do with an expect script. Interactive command line isn't everything. It's really great when you've actually got proper APIs. And I think because of all the crappiness of the cloud in many ways, we've had to rebuild systems that we use there to be resilient so they can actually cope with failure. And this is probably something we should have started doing a lot more, but it was sort of forced on us by the cloud. So How many of you are in a big fancy data center with lots of sort of awesome functionality of interconnects and telcos and ISPs coming in and out? And how many are just, yeah, how many of you are using a data center with interconnects? Am I using the right term? Okay, cool. I don't think you have to be huge for it to make sense. This doesn't really fit this slide, but I just really wanted to use this picture because this is what modular synth people are like with their patches. Yeah, cabling standards do not exist in the synthesizer world. But I don't think you just have to be huge for data centers to make sense. There's an argument I get into regularly with a bunch of coworkers that they're like, well, you know, everyone should be using the cloud until you hit Facebook size. And I think that's just kind of stupid. You know, you've got to put out money for operational expenditure when you first get started, but I don't think you need to be really huge to take advantage of owning all of your own hardware. Interconnects are really cool, you know? Where are your users? A lot of the time they're coming in from commercial ISPs, and where do they go? They go often into these same data centers. So hosting your stuff inside a colo where you can actually have an interconnect agreement with the ISPs that all your users are coming in on, also with the cloud providers. Because again, the cloud is just someone else's server. They're all in data centers somewhere. They're all creating peering arrangements and interconnects with all of the other data center people. So hosting things there sort of can give you the best of both worlds. And I think one of the things that's really cool about this is that cloud providers have started realizing this. You can run a VPC on Amazon that only goes through your data center. You can actually sort of maintain that point of control if you really, really need it. And you can keep your storage on, you can use public cloud with private storage, you can mix and match. These things are really, really useful. We're doing this now, and you know, we're not that big. We're looking at, because we keep a lot of our stuff in Salesforce as a CRM, we're looking at creating paying for dedicated bandwidth just to Salesforce, because it's really, really cheap. Data centers do a lot more than just give you power and a raw network connection these days. And I think it's worth sort of investigating these things and seeing where you can go with them. Moving to where the users are, this is Rick Wakeman, who also has nothing to do with this slide, but he always wears really amazing outfits. I was trying to get a crowd shot in, but I couldn't. Your users come through the data center. The ISPs are often there. You know, the network traffic is 20 meters away from wherever you're hosting something. Take advantage of that. We're finding, as much as the monoculture of ISPs in the US really sucks, Comcast are going through those same data centers. Users can get a much better experience in many ways, just going directly to your hardware if you've got the right arrangements in place. And so this is another buzzword that I sort of feel a little bit allergic to, but I think there's something here about the software-defined data center. Infrastructure vendors are changing. I think this is one of the cool things about cloud happening and the rise of the Devops movement and the sort of operations being treated more like software development and treating your infrastructure as code. All of these convergences are, the big vendors now actually give us APIs. It used to be horrific. You were always reverse engineering something if you wanted to deal with a router or a switch. It was always manual and interactive. And I think we're slowly seeing things change. And we're even seeing it in some of the most conservative vendors. Network and storage people are not the most forward-thinking vendors in the planet. And I don't mean that in a really sort of pejorative either way, but they just haven't had to change all that much. But we've actually got APIs now. We can actually treat infrastructure like code. We can sit there and we can spin up a Vagrant instance. We can push it out with Packet. We can talk to cloud providers. We can talk to our internal stuff. We actually started using UCS gear internally, entirely because it gave us a whole bunch of APIs around compute that was really, really useful at a lower layer. But I think it's all coming down to automation. The APIs are no good if we just keep using them in an ad hoc manner. It's like sending 1,000 developers off to write a software project and all doing it independently. We need to build things as libraries. We need to make them more reusable. And to do that, we've got to have automation. Because I think if you look at the cost decision when it comes to using a public cloud versus using a data center, it's not just about how much you're paying each month for that public cloud service. It's about the really crappy friction of owning infrastructure yourself if you're not automating it. It's about that sort of, someone files a ticket, they get some compute provisioned, and then they pass the ticket on to someone else, and they get storage provisioned, and then someone else gets network. Those are the things that really suck about owning your own infrastructure if it's not automated. I think one of the reasons people adopted public cloud so quickly is because most IT projects fail. Most projects fail and most projects are shit. And the great thing about a public cloud service, you go, well, you know what, that thing's done, we turn it off and it doesn't cost us any more money. But we can kind of do that with our own infrastructure as well. We should be able to repurpose stuff really, really quickly. As we move to, these worlds of more and more immutable infrastructure, we still need automation. You don't want to end up in a position where you've got 1,000 people running different Docker files. You want to have some idea of what's inside that stuff. You're going to need automation, whatever you use. And I'm really not pushing anything in particular here. This is clearly what we do, and this probably sounds an awful lot like Puppet messaging, but it's the true of all of our competitors as well. You've just got to end up automating stuff. There's so much good open source software out there for infrastructure. It was like we didn't used to write software for ourselves as operations people. We would consume developer software and then someone would tie it together with a whole bunch of bash scripts. And then you'd move on to another company, you'd be like, oh, well, how did we do that thing? Well, it turns out it was a bash script, triggering an expect script, poking a port in inetd, which caused some other service to open. It was completely unusable anywhere else. But I think this is, why sharing is one of the 4 pillars of the DevOps definition. Reusing this stuff makes us better. It lets us, keep building upon what we have. I think operations people have traditionally been really bad at that sort of standing on the shoulders of giants. Developers learnt this lesson a long, long time ago. Reinventing the wheel all the time really sucks. And it's not that all developers are good at this, but enough of them were that we're actually seeing more progress. But it's not just about the tools. And that's why I think the sort of sharing part's important. It's about changing our processes. There's like this really human element to it. And again, sysadmins have not always been the most human-oriented people on the planet. We joked about our users. We, call them losers, things like this. We've sort of got to stop this. Let's build infrastructure in our data centers that we can actually program against, that we can create APIs, we can create libraries, we can share them with other people, and we're doing it for the people who are using it. Otherwise, we're just going to keep being seen as a cost center of going, well, every year they ask for 10% more money and they just buy a whole bunch of hardware, but we're not really sure what they do with it. We can call this DevOps, either with an uppercase D or a lowercase d or an uppercase O, or however you want to actually sort of spell it. We can call it Agile. Or you can come back, and I actually find these people really annoying, who go, this is just how we've done everything all the time. And I just don't think that's true. It's not true of the industry in general. I think we've always had pockets of people trying to sort of treat their infrastructure like something more useful for the users, but it's not true. I think this is one of the big things we've got to really push for. The open source projects we have around data center automation, they're no good if we don't have APIs from our vendors. Pick the vendors who actually give you an API. Hassle your resellers. Tell them, I don't want to buy that switch until I can do something programmatic with it. I don't want to buy that bit of storage until I can actually do something with it. We've got to kind of apply that pressure as well. We don't have to accept it. I think there's enough vendors out there now who get it that we should give them our business instead. If people aren't going to give you the APIs to automate with, don't buy their stuff. This is, I think, a common theme around we should build self-service stuff, but that doesn't mean we should abdicate our responsibility as operations people. We still kind of know how things should work. We just got to kind of twist our mindset, think about the users instead, and define best practices and work out how to give people a way to control that themselves. It doesn't mean we just sort of give up and go, let's all go no ops. We're just going to give people raw infrastructure and let everyone in the business kind of go crazy with it. It's not responsible. It's not going to be a good way to deal with the company you're building. You're going to waste money. It's going to be inefficient. And you're going to end up with unreliable stuff. But just because we are the sort of domain experts and know how something should be done, doesn't mean we should exert control all the way through that pipeline. Let users provision stuff on their own. Let's not have these sort of change maintenance meetings where we're sort of meeting once a month to decide whether or not something's going to happen. Let's absorb some of the constraints of the cloud and just sort of deal with it. And let's make sure we're delivering things people actually want, but we're designing it for them. This is one of my favorite bits of software. This is a bit of software called Reactor. I think Native Instruments, the company, are actually here in Berlin. And patching software before Reactor all looked like this. This is essentially virtual modular synthesizer stuff. You create signal processing things. These menus go on forever and ever and ever. And you can build these crazy nested things. And there's a whole bunch of other software in this space that all used to look like this. The thing I think is cool about Reactor is you've got this distinction between the module underneath that you're patching together and the interface you build for it. So this is the same software. This is just like an alternate view. These things all map to the complexity underneath. And so the thing I really liked about Reactor is, like, I was in a band, we did a whole bunch of stuff with this. Most of my bandmates didn't care at all about this stuff. And they're just like, why are you fiddling around with that? But I could sort of package it up and give them these nice interfaces that they could then automate. And I think that was the other key. You can just click on one of these knobs and go, I want to open this up for automation, twiddle a MIDI knob somewhere else on a bit of hardware, and suddenly those two things are mapped together. And I think this is a really good philosophy for us to think about. We're going to always have mess and crap to deal with, because I think, infrastructure in some ways can be inherently messy. But we should be able to package it up and give people the right kind of knobs, the right kind of automation to do what they want with it. And we shouldn't exert control over all of that stuff. So what are the things we have to do? And I think you've probably heard all these messages before, but let's think about it when we're building our own data centers. Assume everything's going to break. Because I think when you assume everything's going to break, you end up building better stuff. I think this is one of the things the cloud has done. Performance is really crap. I have to deal with this outage. I'm having all these changes forced on me. Build it so that it copes with it. I get really frustrated at people who respond to, fragility in a system and go, you know what we need to do? We need to restrict it so changes only happen on the third Friday of every month, and the approval process happens 2 weeks before that. This just kind of sucks. If we just build things assuming failure at all the layers of our infrastructure, we're going to end up with things that are much more resilient, we can create change much faster, and we can put more control in the hands of end users. Users will break stuff. They will abuse things, they will create they will consume too many resources, all of these sorts of things. But if you assume everything's going to break, that'll be fine. You just turn off their accounts, you move services from one area to another. We should be able to kind of deal with this. And one of the things I really like about having a fully automated system is you don't need the same kind of disaster recovery. Your disaster recovery processes your tests can all be about how you actually respond to failure, rather than sort of having this big, 6-month sort of process where you go, okay, we're going to do a DR exercise now where we're going to fail over. You should be doing that all the time. If we've embraced failure, if we're actually sort of assuming everything's going to break because it's crap, you just sort of end up in a better place and you're building better services on top of it. Small components. This is one of the revolutions, I think, in the last few years of synthesizers. These things here are all tiny. They're like this big. I think because the performance sucked in the cloud, we started building more small components. We stopped just going, here's a box, there's a huge monolithic layer, let's have it all communicate internally. It's that same security model of it's crispy on the outside, but it's all a mess on the inside. Being forced to move to small components for things means they're more easily replaceable, they're more easily scalable, you've got more formalized interfaces between them, you can upgrade things in parts, rather than just creating these apps that no one knows how to run. This is one of the most terrifying things whenever I talk to, particularly banks, because they've got all your money, but they have these apps that someone wrote, and they'll bring in a contractor, and someone will have, historical ancestral knowledge about how the thing actually works, and everyone's afraid to really touch it. And if we move to a world of small components, it's easy to change things. We can take one bit, we can get rid of it, and we can replace it with something else. And it means we can build tools to do that. It's really hard to build big software projects. Software is not easy to build, but it's much easier to build small things once everything's reduced to that sort of a component. So I wanted to kind of say this again, just because it's so cool how much stuff's out there at the moment. It was so frustrating, I think, in the 90s being a sysadmin going, wow, I'm building almost everything myself. But we've actually got these big successful projects going on. You know, we're talking about a lot of them here, you know. Mitch is here. We're talking about Vagrant. Like, I couldn't live without Vagrant anymore. I don't know how I did Puppet development before it. Just being able to have these fast feedback cycles. We've got lots of really, really cool stuff. It's kind of an exciting time to be in operations. Thank you. So if anyone had any questions or just thought I was wrong or anything, feel free to yell at me. Bern promised me he had a question. I think your comment this morning was, we invented Stoic. Germans invented being Stoic. You could also tell me where's a really good place to go listen to techno this weekend, if, you know, that works too. Or you can just come tell me afterwards. Sure. Yes. So,
please repeat the question.
Yeah, I'll repeat the question. How far should we go with expecting failure? You know, Netflix talk about this a lot. Has everyone heard of, you know, the Chaos Monkey and the Chaos Gorilla project they made? It's basically they wrote a bunch of code to just make stuff fail all the time. And they can do that because they're really, really huge and they built this big resilient architecture. You know, the more testing you do, the better. I think one of the coolest things I learned from being at Google was their dirt exercises they would do, where you'd sort of tell everyone, hey, there's going to be a disaster test in August, and you wouldn't really have any other details. And then everyone else would sit there planning it, and we'd actually push shell scripts out to all of the boxes, just creating firewall rules to simulate outages. And there were sort of safe words you could call up. But if you ran a service, you were told there's going to be a whole bunch of outages, all of your processes have got to kind of deal with that. If all of you are in, it might be that one whole office goes away, so you need to make sure your documentation's up to date. One year it was awesome, because the exercise was that an earthquake caused Mountain View to fall off the side of America. And I was in the Mountain View office, so we just sat there and watched all of the other teams try to read our documentation. And you could get an exemption for your service. You could go, look, I'm really not ready for the disaster exercise, and you'd get an exemption through all the firewall stuff. But everyone got really shitty at you for that, and it was kind of this really black mark. I thought that was an amazing sort of exercise. We did one the other day. We had to upgrade a core switch in our data center, and my network guy, who's really, really into this stuff, was like, I'm running the whole thing like it's a disaster. And so he was there, flipped the core switch, and basically all the remote people had to kind of deal with it, and he just sat there and documented all the things that could go faster and faster. And I think they did it at 1 in the morning, and it was services that were only used during the day, so it didn't actually have any impact. But you know, those things are really, really cool and really useful, and they're sort of fun. Did that answer what you were getting at? Yeah. Okay.
Any further questions?
I'm waiting, Bernd. Yep. Yeah. So I think as far as noisy neighbors consuming resources on the same hardware you're on, I don't think it's as much of a problem as it used to be. Mainly because they'll charge you if you want to be insulated from that. You can pay more money and you won't be. But definitely on the really small instances, like if you launch tiny Amazon instances, we see really big variations in performance there. As far as I think it is really interesting seeing how different things are between the US and Europe as far as public cloud consumption goes. I think that the standard sort of wisdom is that Europe is more complicated in terms of regulation, and you might have laws saying if I'm in Belgium, my data can't actually leave Belgium. And I know there's a few checkboxes depending on which country you're in. You're launching stuff from your AWS console, but I don't think that's kind of the whole story. I think, and again, I'm not a cloud hater, but I think the hype bubble started in Silicon Valley and spread out. And it's probably got an inverse square law or something as geographically in terms of how susceptible you are to the hype. Yeah. We use, and this is just personal anecdote, not kind of, I guess, endorsement, but there's this really cool little service called Cloudability that you can just wire up to that AWS billing API. And we actually got really, really sort of strict about this recently. Everyone at Puppet Labs has to tag instances in the same way and go, this is the owner, this is the project, and sort of tag it with a consistent set of metadata. And then we've just got other scripts that destroy every instance every hour that aren't tagged properly. And because they're tagged, we can actually sort of feed it into this thing called Cloudability and actually go, we're doing scale testing on Puppet Enterprise, and that cost us $15,000 this month instead. So that was the thing that actually gave us a lot of insight into switching a lot of that stuff onto on-premise stuff. Because I think the rough sort of numbers were that we're sort of spending $20,000 a month on stuff that we could spend $80,000 on hardware and get the same kind of goals. And it was sort of a little different for us because the sysadmins at Puppet Labs know Puppet really well, and so they can kind of push out automation, and the friction's really, really low. But I think those sort of cost equations, it's not really in the interest of the cloud providers to make that super transparent. But I think they're going to have to. And if they don't, we're going to keep seeing little services popping up and filling the gaps. Cool. No more questions?
Perhaps one question from me. How many servers do you run in cloud at Puppet Labs? So at AWS or AWS?
Oh, man.
So
it depends.
Just a
so
ratio.
actually, most of our services, so I think the Forge is on Google Compute at the moment, but we're looking at other options. Most of our stuff we're actually trying to move on-premise. We use UCS hardware, but we hate SANs, so I'm sorry, anyone who works for a SAN vendor, but debugging iSCSI is never my idea of a good time, so we're just running ZFS, NFS for our sort of storage layer. I think when we're doing scale testing, we'll create thousands and thousands of instances an hour, but they're often sort of ephemeral. Like we'll spin up an enterprise master and go, hey, does this work with 3,000 hosts? Where does it fail? As far as public services go, it's really just sort of things like the websites and things that we can want to hook into a CDN more easily. I realize that was a really crappy answer. Part of the reason is that I don't actually do it anymore, and my sysadmins kind of get to manage their own budget in a lot of ways, except when it's lots and lots and lots of money.
Okay.
Cool. Thank you.
Thank you too.